my channel. This video is about examples of solving linear first-order ordinary differential equations of the form y prime plus p sub xy equals q sub x. If you are not a subscriber, please hit that subscriber button and please like the video. Thank you. Number 1, solve dv dt equals 9.8 minus 0.25 v. So step number 1 is write in the proper form. So we need to write the equation in the proper form. And here, since our variables are v and t, that would be v prime plus p sub t times v equals q sub t, where t is the input variable. Now, what can we notice? First of all, v prime is equal to dv dt. So that gives us v prime equals 9.8 minus 0.25 v. Then all we need to do to get this equation into the proper form is just move the negative 0.25 v from the right side to the left side by adding 0.25 v. And that will give us v prime plus 0.25 v equals 9.8. And notice that's the form v prime plus p sub t times v equals q sub t. The second step is to identify p sub t and q sub t. Identify p sub t and q sub t. Now let's write out the main form. V prime plus p sub t times v equals q sub t. So when we compare this, that means p sub t is equal to 0.25 and q sub t is equal to 9.8. Number 3, find the integrating factor I sub t. I sub t is equal to e to the power of the integral of p sub t dt. Now recall, in the previous step, we determined that p sub t is equal to 0.25. So this means that I sub t equals e to the power of the integral of 0.25 dt, and the integral of 0.25 dt is e to the power 0.25 t. Number 4, find the general solution. And the general solution is found by using the formula I sub t times v equals the integral of q sub t times I sub t dt plus c. Now, recall from step number 2, we know that q sub t equals 9.8. In step number 3, we found I sub t to be equal to e to the power of 0.25 t. Now substitute those into the formula and then do the integral and simplify. So e to the power of 0.25 t times v equals the integral. Now what I would recommend, since q sub t is a constant, just write this as the integral of 9.8 times e to the power of 0.25 t dt, and then just add on your constant plus c. So e to the 0.25 t times v. Now we do this integration, that would be 9.8 divided by 0.25 times e to the 0.25 t plus c, e to the 0.25 t times v. 9.8 divided by 0.25 is 39.2 times e to the 0.25 t plus c. Now this next step will divide everything by e to the power of 0.25 t. So basically all terms on both sides get divided by e to the 0.25 t power. And will give us v equals, because those cancel, equals 39.2 plus c e to the negative 0.25 t power. And this is the general solution of this linear first order differential equation. Number 2, solve ty prime plus 2y equals t squared minus t minus 1. And step number 1 is write the equation in the proper form. So we want to get it in the form y prime plus p sub t times y equals q sub t. We have ty prime plus 2y equals t squared minus t minus 1. What do we need to do to get the equation in this form? Basically divide every term on both sides of the equal sign by t, because notice that your y prime does not have a coefficient of 1. How do we give y prime a coefficient of 1? Divide all terms by t. And that will give us y prime plus 2 over t times y equals t squared divided by t is t. Negative t over t is negative 1 minus 1 over t. So this is of the form y prime plus p sub ty equals q sub t. Step number 2, identify p sub t and q sub t. Now remember, the form of this differential equation is y prime plus p sub t times y equals q sub t. Now Now, p sub t is the coefficient of whatever function or constant is multiplied times y. So p sub t is equal to 2 over t, and q sub t is whatever the equation is equal to. So q sub t equals t minus 1 plus 1 over t. Number 3, we need to find the integrating factor I sub t. And in step 2, we determined that p sub t was 2 over t. So the integrating factor I sub t is equal to e to the power of the integral p sub t dt. So that will be e to the power of the integral 2 divided by t dt. So that is equal to e to the power of 2 natural log t Now, the thing to do is remember when a constant is multiplied times a logarithm, we can bring that to the inside. So make that e to the power of natural log t squared. And since natural log is base e, that's just equal to t squared. So the integrating factor I sub t is just t squared. In step number 4, find the general solution. And we know that I sub t equals t squared, and q sub t is equal to t minus 1 plus 1 over t, and then we use the formula I sub t times y equals the integral of q sub t times I sub t dt plus c. So this will be t squared. Let's substitute in the values of I sub t and q sub t and do this integral. So t squared y equals the integral of t squared times q, which is a quantity in parentheses, t minus 1 plus 1 over t dt plus c. So t squared y equals, let's simplify the parentheses first before we integrate. So distributive property, t squared times t is t cubed. T squared times negative 1 is negative t squared. T squared times 1 over t is just t. dt plus c. Now we'll integrate t squared y. The integral of t cubed is t to the 4th over 4. The integral of negative t squared is negative t to the 3rd power over 3. Integral of t is t squared divided by 2 plus c. And now to solve for y, we'll divide all terms by t squared. Remember, you even divide your unknown constant by the integrating factor when you solve differential equations. So t to the 4th divided by t squared, that will make that t squared over 4. T cubed over 3 divided by t squared would be minus t over 3. T squared's canceled, so that's plus the fraction 1/2 plus ct to the negative 2nd. So this is the general solution of this differential equation. Number 3, solve ty prime minus 3y equals t to the fourth sine of 2t minus t cubed plus 4t to the fourth. Step number 1, write in the proper form. So we need to write this equation in the proper form. And that proper form would be y prime plus p sub t times y equals q sub t. So notice that the y prime is multiplied by t. So all we need to do to get this equation in the proper form is just divide all terms on both sides of the equal sign by t and then simplify the division. So we'll divide every single term on both sides of the equal sign by t. So t over ty prime, that is just y prime minus 3 over t times y. T to the fourth divided by t, that would be t cubed sine of 2t. T cubed divided by t, that's negative t squared. T to the fourth divided by t, that would be plus 4t cubed. So this is now in the proper form. That should be y prime. Y prime plus p sub t times y equals q sub t. Step number 2, identify p sub t and q sub t. Our equation is y prime minus 3 over t times y equals t cubed sine of 2t minus t squared plus 4t cubed. Now, the form of this differential equation is y prime plus p sub t times y equals q sub t. So p sub t is whatever is multiplied times y. So p sub t equals negative 3 over t. Q sub t is whatever this equation is equal to. So it will be all of that. T cubed sine of 2t minus t squared plus 4 times t cubed. Step number 3, find I sub t. In step number 2, we know that p sub t is equal to negative 3 over t. The formula for I sub t is equal to e to the power of the integral p sub t dt. So this would be e to the integral of negative 3 over t dt, and that's the integral of negative 3 over t dt, so that's e to the negative 3 times the natural log of t dt. Now use the exponential property of exponents. You can rewrite this as e to the power of natural log of t to the negative third power. And since natural log is base e, that drops out, so that is just t to the negative third power. So the integrating factor, I sub t, is just t to the negative third power. Number 4, find the general solution. From step 2 and step 3, we found that I sub t equals t to the negative third power, and q sub t equals t cubed sine of 2t minus t squared plus 4t cubed. Now remember that the general solution is found using the formula I sub t times y equals the integral of the quantity q sub t times I sub t dt plus c. So I sub t is t to the negative third, and that will equal the integral of t to the negative third times the quantity t cubed sine of 2t minus t squared plus 4t cubed plus c. Let's do the distributive property inside the integral. Remove the parentheses so we can integrate. So t to the negative third times t cubed, that's 1. So that's just the integral of the quantity sine of 2t. T to the negative third times negative t squared, that's minus 1 over t. And then we multiply t to the negative third times 4t cubed, so that's just plus 4. And that would be dt plus c. There should be a dt right there. Now we do the integration. Integral of sine of 2t is negative 1/2 cosine 2t. Integral of negative 1 over t is this negative natural log of the absolute value of t. Integral of 4 is just plus 4t, and then that would be plus c. Now divide all terms by t to the negative third. Even the constant gets divided by that integrating factor. So we simplify this, that's y equals negative 1/2 t cubed cosine of 2t minus t cubed natural log of the absolute value of t plus 4t to the fourth plus ct cubed. And all of this is the general solution of this linear first order ordinary differential equation. I hope this has helped you to have a greater understanding of solving linear first order ordinary differential equations. And please watch for more videos in the future. Thank you.